When I was 17, I worked in the maintenance department at a circuit board factory. During my training, they told me that they use 270 chemical compounds in the production of their product. 270 chemicals, and that's just one product. That got me thinking about the people who made the chemicals that we use to make circuit boards. I mean, sure, chemicals are dangerous. Some can burn you. Some are poisonous. Some are known to the state of California to cause cancer, birth defects, and other reproductive harm. But chemical reactions, they do all that and more. Some fizz, some bubble, some smolder, some burn, some explode, some really explode, some really explode. You get the point. Chemistry is dangerous. Which brings us to our project. We're going to make a robot that can do a chemistry experiment. Specifically, our objective is to produce a device that can locate, pick up, and pour at least one test tube into a beaker. The robotic mechanism could take several forms, but all of them will have three basic building blocks. The grabber, which is responsible for picking up and pouring the test tube. The body, this is responsible for moving the grabber around. And the test tube finder, which is used to find test tubes. Much of this project will be about motion control. We will use potentiometers with DC motors to give motion feedback to our control algorithms. The structure will be made from aluminum or wood to save costs, and we will most likely need some length of lead screw, like this one from Amazon. There are many ways to find the location of the test tubes, but one methodology we have right now involves two ribbons of aluminum foil. One is mounted against a solid surface, while the other is strung parallel to the first strip and the surface without making contact. This apparatus will then sweep across the space. If it collides with something, the two strips of aluminum foil will be shorted together, completing a circuit. Depending on where the object was when it made contact, the resistance of the foil will be different, allowing us to deduce the radial distance. Combine that information with an angular reading from an encoder or potentiometer, and we'll have everything we need to locate our test tube in 2D space. The application of a device such as this one is to automate chemical experiments and allow researchers and employees to maintain a safe distance when performing unsafe reactions. Thank you.